All right, this is lesson 22, measures of central tendency and IQR. So measures of central tendency, you have mean, median, and mode, which you've probably heard of before. Your mean is your average value of all the data. To find the mean, I add all the values together and then divide the sum by the number of values in the data set. The median's the middle number in the set when the values are arranged from smallest to largest or least to greatest. Okay, mode is the number that appears most often in a set of data. So data does not always have a mode. Sometimes there is no mode. Sometimes there's more than one mode. So example 1, find the measures of central tendency for the following temperatures: 34, 26, 47, 12, 18, 22, 50, 37, 32, 23, and 34. To find the mean, add the values. So I add all these numbers up. There's 335. Then I divide by the total number of values. There's 11 of them, which gives me 30.45. So that's the mean. The median, I put these numbers in order from least to greatest. And then I can actually cross numbers off, which I found can be helpful. So 12, 50, 18, 47, 22, 37, until you get to the median or the middle. In this case, 32. So if two numbers are in the middle, I add them and then divide them by 2. So in this case, the median is 32. To find the mode, find the value or values that occur the most. If 2 or more values have the highest frequency, then record those values. So in this case, the only number that actually occurs more than once is 34. So the mode of the data set is 34. You also have measures of dispersion. So measures of dispersion include the range, which is the difference between the minimum and maximum values of the data set. So in example 3, I want to find the range of the following data. So I find the highest number and the lowest number. So in this case, the minimum is 9, the maximum is 89, and I subtract them, which gives me 80. You also have quartiles and the interquartile range, or IQR. So the word quartile is the formal name for dividing the data into 4 equal parts. So quarter, think of 25 cents or a fourth of a dollar. To find a quartile, find the median and then find the median of each half of the data. So the interquartile range, or the IQR, is the difference between the first and third quartiles. The diagram below represents ordered data separated into quartiles. So BATA, they're separated into 4 equal parts. Example 4, find the interquartile range of the following data. So 12, 17, 34, 56, 32, 23, 83, 31, 9, and 36. To find the interquartile range, we first need to find each quartile by ordering the numbers. So always start by ordering them from least to greatest. Now I find the median and label it Q2. So I'm going to cross off. Okay. I have 2 numbers in the middle, 31 and 32. So I'm going to add them together and divide them by 2. So 31.5 is my Q2. Okay. Now I find Q1 and Q3. To do this, I find the median of the 2 halves of the data. So right here is Q2. Okay. So this is my first half of data and this is my second half. So when I find this, okay, so 31, 12, 23. So this is my first number. And I can do the same thing on this side. 36 is my second number. Okay, so that's where I get those values from. So therefore, Q1 is 17 and Q3 is 36. So I need to find the interquartile range. So I subtract 36 minus 17, I get 19. So the IQR is 19. So applying measures of central tendency, the measures of central tendency, including the mean, median, and mode, can be used to make predictions. So sometimes data includes outliers or data points that are separate and different from the other data points. A lot of times they don't make sense to the data that is being presented to you. So like if you had 2, 3, 4, 5, and then 40, 40 is an outlier because it doesn't make sense with the data that's being presented. It's almost kind of like a mistake type of thing. So outliers can often affect the measures of central tendency by skewing the data differently. So basically what that means is it bumps everything off. So like if you had 1, 2, 3, 4, 5, and then 40, that 40 is going to really bump up your mean. It's going to change your median. It's going to change everything, okay? So the median or middle number is affected by an outlier, but not as much as the mean. The mean is really the number that's affected the most often by this outlier. So therefore, when describing the center of the data, the median is a better choice if outliers are present. Okay. So test scores for a particular exam are listed below. Data set B includes a student who was not present for the material, but took the test and scored very low. Okay, so here's data sets. And then we've got this 12. So data set A excludes this student. How does the outlier 12 affect the mean and the median? Okay, so data set A has a mean of 78.125 and data set B has one additional value, an outlier that is 12. The mean of data set B is 70.778. The outlier 12 lowered the mean by nearly 8 points. Okay. So the median of data set A is 77.5 and the median of data set B is 77. The outlier had only a slight effect on the median, the middle number. Okay. Since the median does not change as much when an outlier is present in the data, it is a better choice to give you some information about this exam. So the median score, the middle score was about 77.5, which is actually a decent score. Okay. So that is the end of lesson 22. Go ahead and work on the exercises below.